All right, so in this video, we're going to evaluate the following integral. The integral of cosine of kx dx, where k is a constant. So how do we evaluate this integral? Well, we could do a u substitution by setting u equal to kx. And therefore, du is just going to be the derivative of this thing. We're going to take the derivative of it with respect to x, and therefore that would be k. And then, of course, we have to put a dx afterwards. We can divide the k to the other side. We get 1 over k du equals dx. So what we're going to do is we are going to substitute kx for u and dx for 1 over k du. Now, 1 over k is just a constant, so we can pull that to the outside of the integral. So the integral that we're evaluating at this point is just the integral of cosine of u du. But if you recall, the integral of cosine is just one of our basic trig integrals. We know that the integral of cosine is sine. So this is what we get. And of course, we have to add a plus c. So now that we've evaluated our integral, we're going to resubstitute u back in terms of x. So we're going to replace u with kx. And so this would be the answer to this integral. But wait a minute. What if k equals 0? Then you'd be doing 1 divided by 0, and that's undefined. So clearly, this is not the answer to our integral if k equals 0. This is true, however, as long as k does not equal 0. So then what if k does equal 0? Well, then you'd have the cosine of 0x, which is cosine of 0, which is 1. You'd have the integral of 1 dx. The integral of 1 dx is x, so you would get x plus c. I'll just differentiate between these constants, and so this is true if k is equal to 0. So this would be the complete final answer to this integral. Right, this is probably the answer that all of you guys are looking for, right? That was good. No, I'm just kidding. But seriously, you do actually have two answers if you are saying that k can be any constant. And so yeah, this is pretty much it for this video.